Hi, I'm Pat Keeney, an instructional designer with K-12. Along with my assistant, we're here to work with you on a lab that explores the viscosity of honey. In most lab work, advanced preparation is needed and safety is always important to consider. Viscosity is a fluid's resistance to flow. While substances, such as honey, are described as being viscous, all fluids can be characterized by their viscosity. Molasses, motor oil, and honey all have high viscosity. Water, juice, and rubbing alcohol all have low viscosity. In this lab, you will see how viscosity responds to temperature. The important question to consider in this lab is, how does viscosity change with temperature? Viscosity indicates the thickness of a fluid. Specifically, viscosity is a fluid's resistance to flow. In this experiment, we will warm up cold honey and then measure how it flows down a ramp to demonstrate how temperature and viscosity are related. Use your observations and prior knowledge to write a hypothesis that describes how viscosity changes when temperature changes. A good hypothesis should take the form of an if-then statement, such as, if the temperature increases, then, you finish the rest. Honey packets can be made in advance by putting 1 tablespoon of honey in 7 snack-size, zipper-closed plastic bags. Or you may obtain honey packets in a cafeteria or restaurant. Freeze the honey packets for several hours. We made a tray of ice cubes, which was needed to lower water temperature during the experiment. Before beginning the lab, we will create a data table with the following columns: temperature in degrees Celsius and distance covered in 30 seconds, measured in centimeters. We'll get our ramp ready by placing aluminum foil under one end of a cookie sheet to catch any spills. First, we tape a metric ruler to a cookie sheet lengthwise, with the 30-centimeter end near the bottom of the sheet. Then we add a piece of tape to create an easily visible reference point as a starting line. Now we're ready to get started. We put a thermometer in a large plastic container and then filled the container with water that was about 70 degrees Celsius, slightly colder than what is needed for hot tea. We then recorded the water temperature in the data table. We were concerned about some safety issues. For instance, if the water is too hot, it would melt the plastic honey packets. Never microwave honey packets. They will heat up extremely fast and the microwaves weaken the plastic. The packets may break when you handle them. Hot honey can cause bad burns because it sticks to your skin. To warm the honey, we placed a honey packet in the water for 5 minutes and then removed the packet. To get the best lab results, we sealed the packet securely before placing it in the water and dried the packet when we removed it from the water. This avoids mixing any water with the honey. Water may alter the viscosity of the honey and therefore could compromise the experiment. Next, we removed the packet from the water, dried it, and then used scissors to snip off the corner of the packet. With the cookie sheet flat on the work surface, honey was squeezed onto the sheet near the 0-centimeter end of the ruler. We lifted one end of the cookie sheet off the table and onto the container so that it was angled, allowing the honey to flow down the sheet toward the 30-centimeter end of the ruler. To get the best lab results, understand that certain things may vary, such as the honey itself, the indoor temperature, or even the type of cookie sheet. In the first trial, if the honey moves too fast or too slowly, we could increase or decrease the time of the trial, or tilt the cookie sheet more or less. After the first trial, we have to be sure to always use the same setup for each succeeding trial. Notice that we were certain to wipe all the honey from the cookie sheet. We repeated the entire procedure using water at approximately 40 degrees Celsius to warm the honey. Then again using room temperature water at about 20 degrees Celsius, and in ice-cold water at approximately 0 degrees Celsius. We used ice to lower the temperature of the water. You probably understood before beginning this lab how viscosity is related to temperature. Now that you have seen this lab conducted, you should be able to describe that relationship. You will be provided with data from this experiment and possibly others like it. In all cases, the same procedure